might be divided by 3. So that means if I have, right, here's a square prism, here's a square pyramid. So everybody look up here, unless you're copying. This right here, the formula for this is area of the base times the height. The formula of this is area of the base times the height divided by 3. What does that mean about the relationship between these two? So this one's area of the base times height. This one's area of the base times height divided by 3. What does that mean about these two? This pyramid volume should be 1/3 of the volume of this. So if this is 100, this should be 1/3 of 100, right? Or in other words, how about this? If this one is 10, what should the volume be of this one? It should be 30. It should be 3 times this amount. So whatever this volume is, if you take 3 of these pyramids should fit into one of these prisms, right? That's why we have divided by 3. So we're going to watch a quick little video and we're going to see if that's true or not. Do 3 of these pyramids make up one of these prisms? And if they do, it's a really great visual to see why that formula is what it is. So we're going to watch a quick video, and then I'll put this back up. It's like a 2-minute video, so when I say quick, it's very, very quick. Where's my clip? I'm just right in front of me, my God. Okay. No thanks. All right, so we've got a square pyramid and a square prism. So let's see what happens. Isn't that wild? So 3 square pyramids make up 1 square prism. Huh. Okay, now we've got a triangular pyramid and a triangular prism. If the bases are the same, it should be that 3 of the pyramids make up 1 of the prisms. It doesn't look like it would be, right? Okay, and then the last one, if you have a cone, 3 cones should make up 1 what? What is that? 1 cylinder. Wild, right? Just wild. Also, I do just want to share that guy has like 1,000 views, and I feel like if I were to make the same video, maybe I could also get 1,000 views. You know what I mean? Like, he's like famous, and like I could be famous on YouTube. I could do that. You know what I mean? So that's just a side note. Okay, so that's where the divide by 3 comes from. So it's the same as the area of the volume of a prism, excuse me, except if it's a pyramid, it's 1/3 of that volume. So that's why we divide it by 3. It takes 3 pyramids to fill up 1 prism. Okay. Okay, now I believe I asked you to finish question number 5. Yeah, I did. Oh, yeah, I did. Yeah, some people are shaking their heads. Okay, number 5 was a composite figure. I don't know if we wrote that down next to it. This is called a composite figure when it's more than one shape put together. So if it's like a prism and a pyramid, it's called a composite figure. So this one over here, composite figure. It just means you have at least 2 different figures that make up the one 3D shape. Now, in number 5, you've got 2 different shapes. At the bottom, you have a prism. At the top, you have a pyramid. To find the full volume, you're going to find the volume of the prism, you're going to find the volume of the pyramid, and then you're going to do what with those numbers? You want to get the full volume. I'm going to add them together, exactly. So I'm going to give you a moment right now. I'd like you to try number 5. I want you to find the yes, you can find the volume of a prism. It's easy. And you can find the volume of a square pyramid. It's also easy. Give it a try. Give it a try. It's the easiest problem on this paper. Give it a dang try. Try. You know how to find the volume of a prism, especially a square or a rectangular one. Length times width times height. Ooh. Give it a try. And then when you're done, put your pencil down so I know you're done. About 30 more seconds. All right, let's take a check. So you're finding the volume of the prism, volume of the pyramid, and then adding the 2 together. How do you find the volume of a prism? Length times width times height. Good. So if you look at that box at the bottom, what's the length, width, and height? 9, 9, and 8. Good. So what did you get as your volume of the prism? Did you get 648? Good. Easy peasy, right? Now, volume of the pyramid is 1/3 area of the base, times the height. Or in other words, area of the base times the height divided by 3. Now, if you're looking at that pyramid, what is the shape of the base? Just the pyramid. It's a square. How do you find the area of a square? Base times height or length times width. So if you're looking just at this pyramid, what's the length and width of the pyramid? 9 times 9. Good. So the area of the base is 81. Actually, I should say square, not a rectangle, my bad, but that's okay. Now, what's the height of the pyramid? 10. So now I'm going to take the area of the base, my 81, times the height, which is 10, and then I'm going to divide it by 3. So area of the base, 81, times the height is 10, and then I divide that number by 3. So my volume of the pyramid is 270. Now, last step is I have to do what? Add the two together because I want to get the full volume of the composite figure. So my full volume, my total volume, is 918 feet cubed. Feet cubed. Don't forget to put that in. If you forgot, write it in now. Have to have the units. Okay, so area of the base shape was a square. So area of a square is 9 times 9 here. Height was 10. Multiplied those two, and then I divided by 3 because it was a pyramid. All right. What questions can I answer about that problem? Feeling pretty good about a pyramid right now? Feeling okay? Me? All right, flip it over to the back. We're going to do some cones, which are just another type of pyramid. What type of shape is at the bottom of the cone, though? A circle. So it's the exact same thing. It's going to find the area of the base times the height divided by 3. But to find the area of a circle, I'm going to do pi r squared. So when you look at the equation on the back, that's not it, real. When you look at the equation on the back, the equation is 1/3 pi r squared h. The pi r squared is your big B, okay? So don't let that freak you out. Let's just find the area of the circle first. Multiply times the height and divide by 3. Now, you can write it like this, or personally, I prefer to write the equation as pi r squared h and then divide it by 3. I like that formula more. I like the way that one looks a little bit more. So I'm going to use that way, but it doesn't matter. Times 1/3 and divided by 3 are the same thing. So you can write it whatever way your heart's desire. So let's take a look at number 6. You've got a cone. All you need to know is the radius and the height, and then you can plug everything into a calculator. You don't really have any work to do. So what's the radius of number 6? 9. What is the height of that cone? 17. Okay, you've got your radius, you got your height. All you have to do now is take those two numbers and plug them into the equation. It's a problem for your calculator. It's not even a problem for you. So you're going to do volume equals pi r squared h divided by 3. And you're just going to plug in the numbers that are in the equation there. So pi, yeah. Radius is 9. Height is 17. And then I divide that by 3. Okay, so you're going to do everything on top first and then push divided by 3 at the end. So put that in your calculator. Let's see if we get the same answer. Everybody put it in your calculator. I want to make sure we all know how to do it. Do we all remember where the pi button is? EXP at the bottom. Okay. All right, so you put that into your calculator. Let's see if we get the same number. Okay. What number did you get? What was it? Say it louder. With conviction. 1,441.99. Did anybody get anything different? Beautiful. Good job. Now, I'm going to round that. You could put 99, but because it's 99, I'm just going to round it to 1,442 because it's so close. Okay. 1,442. And then what should be my label? Yards cubed. Yards cubed. Easy peasy, right? I think cones are easier because cones are just straight up plug it in. You don't have to find the area of any like shape. You just plug it straight into that equation. Cones are great. All right, I'm not going to do number 7 with you because again, it's just a plug and chug, but what's the radius of number 7? How'd you get that, Daniel? Good. 5 is the diameter. The radius is half of it. It's 2.5. What's the height of your cone? 8. Good. So all you have to do for that one is a plug and chug again. So I'm going to skip it because it's a plug and chug. I'd rather do number 8 with you. All right. Number 8. We need to know the radius. We need to know the height. What's the radius of number 8? How'd you get that, Daniel? Good. This is the what? It goes all the way across. Diameter. That's the diameter. So to find the radius, we take half of it. Half of 27 is 13.5. So from the center to the edge, from here to here, it is 13.5. Now, what's the height of this problem? There's no height. Why not? Why isn't 22.5 the height? It's the hypotenuse. It's slanted. It's slanted. Yes. Number 15. Number 15. Yep. All right. So we don't know the height. I'm going to put an H there. Oh no. What happens when you don't know the height? What happens when you don't know the height? Huh? Yes, you do. When you don't know what the height is, you have to do a squared plus b squared equals c squared. Hooray. Aren't you so excited? Yay. This is my favorite theorem. You have to be excited. I don't care if you're not. Pretend that you are. A squared plus b squared equals c squared. Okay, the only one that matters is the c. Which one has to be the c? 22.5. It has to be your hypotenuse, the number across from 90. So here's the 90. It's got to be across from it over here, 22.5. Now, what are you going to put for a squared? So A and B are the legs of the triangle. Doesn't really matter at all. No. So I'm going to put 13.5 as one of my numbers. I'm going to put it as the first one. You don't have to put it as the first one if you don't want to. And then what am I going to put for b squared? You can either put b squared or I'm going to put h squared. because h stands for height, but it doesn't matter what you put. You're just solving for a variable, so it doesn't matter what letter you put there. I'm just putting h so I remember it's the height. All right, what should I do first? What? Yeah, square the numbers. Square the numbers. Exponents. So you're going to square both of these numbers. Do you remember how to do that in your calculator? You just push the x squared button. Yep, so push the number first, then push the x squared button. All right, so I squared both of the numbers. Now what? Now, subtract what? 182 from both sides. Good. And I'm running out of space. 182.25. Okay. H squared equals 324. And now what do I do to get the h by itself? Now you square root it. Yes. So anytime you got a squared, if you want to undo the squared, you got to go to square root. If you forget that when it comes to the test, just look at your calculator, because look, right above x squared is square root. They do that on purpose. The opposite is right above it. Okay? So shift x squared. You get 18. So your height is 18. Now that's great, but I'm not done with the problem yet. No, I'm not. I still have to find the volume. No, I gotta find the volume now. Okay, so now volume is just plug and chug. What? Do you not like plug and chug? Okay, you're gonna plug it into the equation. Pi times r squared times h divided by 3. Do it. Let's see if we get the same answer. Go. Ready, break. Ow, that hurt. Okay. 0.5. Take 30 more seconds. Plug it in, plug it in. What, why are you giving me, what was the Blade commercial? Plug it in, plug it in. You know that one? Okay, okay. What number did you get? Say it a little louder for me, Daniel.
254.5 kilometers.
Try again. Yes. Anybody else? Is something different? So when you go to plug it in, I have a feeling, Daniel, you did not push r squared, if I had to make a guess. So when you go to plug it in, you're doing pi times your radius squared is 13.5 squared times 18, and then dividing it by 3.
Yeah, I think I forgot.
I think you just pushed r, if I had to make a guess. Well, 13.5, you know what I mean. So you should have gotten this number. Yeah, good. 3,435.3 what? Kilometers cubed. Woo! Okay. How you feeling? You feeling like a pyramid champion right now? Pyramid cone champion? Like this is, you could, no. All right, so now we're gonna do some application questions because when it comes to your exam, all of the questions are application questions on your exam. So you're gonna have so many word problems. Get excited. You're not gonna have a lot of problems on your exam that are just like, here's a problem, solve it. Most of the problems, if not all of them, are really going to be more of these application type questions where you have to read the question, you have to understand what they're asking you to do, and then you're going to have to solve it without them just saying, hey, use the volume formula to do this. You got to know what to do. Okay, so these application questions we're going to start spending a lot more time on from essentially here on out to the very end. Which one? Okay. So I'll leave that one up while we're doing number 9 here. Now, number 9 says, a cone has a volume of 1,309 centimeters cubed. If the height of the cone is 8 centimeters, find its radius. All right. So, what do you think we should do? Write out the formula. Okay, that's a great starting place. So let's write out the formula of a cone. What's the formula? Beautiful. So let's write out the formula to start. Volume equals, and you can write it as 1/3, or you can write it as Ms. Damaso has been writing it with the divided by 3. That's the same thing. Pi r squared h divided by 3. Okay, so that's the equation. 1/3 is the same thing as divided by 3. Yeah, so you can write it either way. I like writing it as divided by 3 because I think it's easier when I go to put it in my calculator. But they both are the same thing. You could put times 1/3. All right, now, what should I do? Plug 8 into h. Beautiful. So what you're doing is you're substituting in the different values. And once you substitute in, we can solve for whatever's left over. So for our volume, we're going to substitute in 1,309 equals, I'm going to leave the pi. I don't know the radius, so I'm just going to leave r squared. Like Daniel said, I know the height, which is 8. And then I'm going to take that whole thing in, divide it by 3. So at this point, while it might not look it, this is a algebra problem. This is algebra because you're going to solve for r. You want to get r all by itself, which means everything over on the right side that's not an r, you have to somehow figure out how to get it over to the left side. And there's a lot of different ways to do it. There's a lot of different ways to do it. So if you had to choose something to do first, what would you like to do? And there's no like right answer here. There's a lot of choices for things you could do to move stuff over. Why would you do that? Cancel the 3 out. Good. This is divided by 3. So to get rid of divided by 3, I'm going to do the opposite, which is multiply by 3. Good. Let's do that. Multiply by 3, multiply by 3. Right, because whatever I do to one side of the equation, I have to do to the other side. So on the left, we're just going to straight up multiply. 1, 3, 9. I get 3927 equals. Now what happens on the right side? 3 cancels out. I'm just left with pi r squared h. Or sorry, 8, not h. My bad. Okay, great. You got rid of the fraction. That's a great first step. I still want to get the r by itself, so I still got to move some things around. Now, again, there's a lot of choices for things you could do. What's something you think you want to do? You can divide both sides by pi and 8. Before I do that, though, you know what I'm going to do to make my life easier? I'm going to combine the pi and the 8 to make it into one number. So then that way I can divide. So instead of having to divide by both pi and 8, I can just divide by one number. So what I'm going to do is I'm going to combine pi times 8. I'm just going to multiply them because this whole equation is multiplication. So I'm just going to multiply pi times 8 and rewrite everything else. So pi times 8 is 25 point, we'll put 13, that's fine. And then I still have times r squared. Right, so I essentially combined like terms on the right. I just multiplied together on the right. And now we're going to do what Daniel said. Now we're going to get rid of that number by doing what to it? Dividing by it. Yeah, this is 25.3 times r. So to get rid of it, I divide by it on both sides. And now I've definitely run out of room, so I'm going to have to come up here. All right, 3927.13. Wait, that's wrong. And amount. Okay, so I got 156 point. Okay, we can put 3, sure. 0.3. I was about to put 27. Equals, what am I left with on the right? R squared. So I'm not done yet. I'm almost done. What's the final step to get the r by itself? Square root it. Very good. So I'll square root. So I'm actually just going to leave that really big number in that I had, and I'm just going to press Shift X squared. What do you get for your r value? 12.5. So my radius of a cone is 12.5, and what should I put as the label? Centimeters. Yep. Just centimeters, right? Because it's just the radius. It's not a volume, so I don't have to put centimeters cubed. Woo! All right. How you feeling? Feeling great? Feeling like algebra geniuses? Okay. 48. What time are we done in here? Okay, we got enough time to do one more. All right, number 10. Oh, I know. Number 10. Let's do the last one. Okay. Number 10. Caitlin must build a sandcastle in the form of a square pyramid for a project as shown to the left. She bought 3 bags of sand, each containing 1,200 inches cubed of sand. Will she have enough sand to build the castle? So I want to know, if she's got 3 bags of sand, each one being 1,200 inches cubed, does she have enough sand to build this castle right here? Okay, you're going to walk me through it. This is a test question. What would you do first? What would you do? What formula? Why?
Because that's what the sandcastle is supposed to look like.
Good. Okay, so the sandcastle is supposed to be a square pyramid. So David's saying, okay, let's start by writing the equation for volume of a square pyramid. All right, what is it?
Base area of the base times height divided by 3.
Okay, good. All right, there's your volume formula for a pyramid. Now what do?
Find the area.
Okay, find the area of the base. So walk me through it. Why? Good. So my shape at the bottom is a square. So to find the area of a square, my big B, I'm going to do length times width, which is 25 times 25. Okay, so what's my area of my base? 625. Okay, now what?
Now you plug in the area of the formula multiplied by 18 and divide it.
Multiply by 18 because the height is 18. Okay, so now we're just plug and chug. Area of the base is 625 times the height is 18 divided by 3, and we'll get the volume. Okay, so you do it. All right, what did you get as the volume of your pyramid? 3,750 what? Inches cubed. Am I done? No. Why not?
Because it's asking, will she have enough sand with the 3 bags?
Okay, will she have enough sand to build the castle? How do you know that? How do you know she doesn't have enough sand? Why? There's 3 bags of sand. So 1 bag of sand is 1,200 inches. She's got 3 bags of it, right? So that's 1,200 plus 1,200 plus 1,200. Or in other words, it's 3 bags, right? Times 1,200. So in total, how much sand does she have? 3,600 inches cubed of sand. That's how much she has. How much does she need? 3,750. This is how much she needs. This is how much she has. So, does she have enough sand to make her pyramid for her project? No, she does not have enough sand. No, not enough sand. How much more sand does she need to build a castle? 150 what? Cubed. Inches cubed. So she needs 150 inches cubed more sand. Okay, if I was a betting woman, which I'm not, but if I was, I would assume questions like that one are really the type you're going to see on your exam. They're going to say, hey, does she have enough? And if she doesn't have enough, how much more does she need? Those are the types of questions you're going to see. All right, babies. So we are done for today. What I'd really like you to do, there are 2 questions left on the back. I would like you to try question 7 and 11, and we'll check them on Monday. Okay? You don't have to turn anything in, but I want you to try them because, like I said, those application questions, those are the ones you're going to see on your test. So the more practice you can get with them now, the better and more confident you're going to feel on your test in just a few weeks, okay? If you borrowed a calculator, please put it back in the correct spot. And then we will do some more practice with these types of problems on Monday. Unless you're not here, in which case, good luck on your exam. Yes, Mayor.